So you've got different levels of putting things together. You've got plumber solder, which is much lower temperature, and it's capable of holding, you're dealing with 50 psi, 100 psi. And so with plumbing solder, you have to use a flux, a chemical, to keep the pipe clean, and much lower temperature, much messier, and it can't handle as much pressure or temperature. So the difference being is when you see that gray solder in a plumbing pipe, and you were to look under a microscope, you would see that the I can't even remember what it's made of. It's not lead anymore, but it looks like lead. It doesn't penetrate the surface very much. If you cut it under a microscope, it's almost filling the gaps. It doesn't penetrate the surface. If you look at silver solder, which is much higher temperature, and you were to cut that in a microscope, you'll see the fissures, and you'll see the brazing rod, the silver solder. It's really penetrated the surface. And then, of course, the next level of joining materials together is welding. So if somebody takes two pieces of steel and they get them both hot enough and they weld them and they fill them with a welding rod and you cut it, they look the same, because it's the same material, it's uniform. So you've completely melted. It's like they're fused together forever. Silver soldering or silver brazing is somewhere in between, and it's really strong for what we're doing. We're dealing with pressures up to 600 psi, and there's no flux involved. So all we have to do is we have to clean the ends of the pipe. So we have to clean the ends of the pipe, and we have to clean the fittings. And if we start off clean, it should stay clean. Now, when this was made at the factory, it was perfectly clean, and now it's oxidized. And the more that's out, this pipe's out in the air, it'll oxidize. And if you have oxidized pipe, it won't braze or silver solder as well. You have to debur the pipe. So you need a copper deburring tool. Yeah. So really affects in water and in refrigerant. If when these are cut with a pipe cutter, the ends are folded in like that. So you need to you're going to clean everything, and you're going to use a deburring tool to clean this off. So we mostly use straight acetylene. Oxyacetylene is very hot. I don't know why people get into oxyacetylene. A blink of an eye, you burn a hole through everything. And you just go, oh. And when we used to deal with much bigger pipes, 1-inch pipes, and you've got a torch in oxyacetylene and you're trying to get it warm, and you get too close and you burn a hole in it. You got to start again. So small diameter this would be like for 3/4, 7/8. This would be for smaller diameter. If you see a flame like that, it's an oxidizing flame, and it will turn your work black. So you want to see a nice little blue cone there, and that's a good clean flame. So you just warm it up. And it changes color. So as it gets brighter, it's getting close, it's getting ready. And you see, I'm actually pulling you can tell it's going into the fitting. So the whole thing glows, and wherever you put the heat is where the silver brazing will go. So if you've got a 7/8 90 and you're using a bigger tip and you're heating it up, you want the solder you want this silver brazing to go all the way in. Once it starts to flow, you just move the torch and you see the whole fitting get bright because you know you can see exactly how far it's gone inside the joint. And silver brazing that's it. That's all there is to it. It's about cleaning the pipe, cleaning the fitting, deburring the inside, and the process itself is really easy. And you can see it flow in. And it's not like plumbing. Plumbing, you get leaks. You don't get leaks. If you see that bright shine all the way around and you've gone round with the rod, it's good. Now the biggest thing that we have is we very rarely put couplings in the middle. We typically buy a 50-foot line set and it's 40 feet between the two. So we've really only got connections at the unit and we've got connections at the coil. So the big deal down at the unit is we don't want to cook the access valves to the equipment. So we can use a putty, a heat block, hot block. So the first thing we do is we take out our Schrader valves with a core removing tool because we don't want to fry our Schrader valves. And then we want to protect the shutoff valve. The shutoff valve is like an Allen wrench. That's how you release the refrigerant. So we want to protect our valve set, and we will take a thing of putty and mold it around the pipe. You can see demos of this where somebody will have the heat block around the pipe and they've got the torch over here and they've got their finger over here. I mean, it is very effective. There's all different brands. There's sprays. This one's a putty. Heat Be Gone is a liquid. There's all different brands on the market. I would always use heat putty, but I would also put a wet rag, double insurance. I'd do both pipes with a heat putty. I'd get a wet rag, put it on there, and then just do your thing. And when it's all said and done, you've just got to put the Schrader valves in, put them back in there. Now, the other thing that we discussed last week is if you really want to do quality brazing, is you should run nitrogen through. Have you seen that done? So interesting, if you braze a piece of Mitsubishi equipment that we're allowed to do, Mitsubishi says we have to run nitrogen through when we're doing it. So generally our line sets are brand new and they got plastic caps on them. They're super clean inside. Our fittings are fairly new and we clean them all up. So the system it's free of contaminants. If we run nitrogen through when we're brazing, you don't get any oxidation on the inside. Now, I didn't run nitrogen through this, so the inside of the pipe will look like the outside. So there's going to be black oxide inside the pipe, right? So quality jobs, you always nitrogen. You just attach nitrogen bottle with a regulator and a tiny crack in nitrogen flowing through, and it will keep the inside perfectly clean. We have these things called TXV valves, and a TXV valve, if it gets dirt or carbon in it can plug the valve up. So it just takes like a couple of minutes to Always, if everybody's got a nitrogen tank, just connect it, trickle some nitrogen in there, easy. And you'll hear it, it gets a little bit difficult on the last fitting, you know, because you can leave one fitting loose and you can do most of your fittings, you know, one of them's like disconnected, and then it's a little harder because you got to have somewhere for just a tiny little bit of nitrogen, but it makes a big difference. And the other thing that we're going to start doing, does everybody know what a filter dryer is? So a filter dryer comes with every piece of equipment. Yeah, usually a little black. Yeah, yeah. So on the liquid coming out of the compressor, there is a filter dryer, and that's what it is. It's just a filter, but we have to silver braze it into the line. Another thing that can be done is to put in a refrigerant sight glass. And you can put this in, you come out of your condenser after your valve, you put your filter dryer, and then you braze in a sight glass. And when a system becomes fully charged, there are no air bubbles in the liquid line. So a lot of guys, like if you've got a sight glass in there, and as a service guy, if you come up and you see bubbles going across there, or you see bubbles in the glass, you know you've got a refrigerant problem. And everything's worth double checking. I mean, what happens if your gauges are broken? Like you could have a set of gauges that are out of calibration, and you've got your scale set up, you've got your refrigeration, you've already figured out I got to put 3 pounds 7 ounces in, so you're weighing in your refrigerant. And if you've got your gauges set up over here, you can be looking at your sight glasses and you'll see those bubbles, and they'll get smaller and smaller, and as you get to the right amount of charge, it goes clear.